So we were writing, no, we were only given information on segment AD. Nothing about angle AED. All right, we ready to try a proof? Don't be scared. All right. So we have statements and reasons. I'm going to write out my given information. All right, so what we do is we go through our given information and we make conclusions and mark the diagram if we can, if we're able to, based on the given information. So when it tells us that ray PS bisects angle RPO, my first question for you, is it okay that the given called it a ray and in the diagram is drawn as a segment? Is that okay? That's absolutely okay. So now when it says ray PS bisects angle RPO, let's trace this angle, R to P to O. When you bisect an angle, you go to the vertex of that angle. Which point is the vertex? Connor? P. You go to the vertex, you go to the middle letter, and then you look inside. Do you see two angles now made inside of that green angle? Yes. So when you bisect an angle, you're going to conclude that you have now two congruent angles. Which two angles can we mark to be congruent? Name it with 3 letters, please. Which 2 angles? Looking for somebody new. Same hands holding up the class today. Caleb, which 2 angles do you think? Angle RPS, yeah. And that's going to be congruent to which angle? OPS, you got it. Remember to stagger your markings so they're not connected. Now, anywhere in our proof, has it been written specifically that angle RPS is congruent to angle OPS? Those specific words written down? No. Do you think we have to write that down for the reader? Absolutely. So step number 2, we've made a conclusion based on the given information. So we're going to say angle RPS is congruent to angle OPS. Don't forget your angle symbols. Now, what made us believe we can do that? What made us believe that we can do that? Adam? Good, because it told us in the given information that we were bisecting the angle. And isn't that based on the definition of a bisector that it splits it into 2 equal parts? So we're going to say our reason for this is def of bisect. And I just write BIS. Is that what we wanted to prove? Yeah, so we're done. All right, number 4. Given DH is congruent to HF. So I marked it. I'm going to write it out in my proof. We want to prove that H is the midpoint of segment DF. Well, based on our markings, do you think it's safe to say that H has to be the midpoint? Yeah, and we have more than enough information to say it right now. So statement 2, I'm going to say what we want to prove. H is the midpoint of segment DF. And who thinks they know the reason for this? Adam? So do you think we're allowed to write because they're both congruent? Excellent, because that's the definition of a midpoint, a point that creates two equal segments on both sides. So this is def of midpoint. I shortcut midpoint MDPT. If I do it, you can do it. All right. So here, this is not a proof. This is an algebra problem. It says given ray KO bisects angle JKM. What can we conclude if ray KO bisects angle JKM? Can we conclude? Bridget? Excellent. Angle JKO is congruent to angle OKM. Then it tells us that angle JKM is represented by 41 degrees and 37 minutes. And we're asked to find angle OKM, this angle down here. Don't get nervous with the degrees and minutes. Let's say, don't write this down, but let's say I told you the big angle was 60. If the big angle was 60 and I asked you to find angle OKM, what would it be? Sophie? 30. What'd you do? Divide by 2. Because what did it say? The big angle's bisected, right? So if the big angle's 60, doesn't each part of it have to be 30? It's the same idea. So now I'm just telling you the big angle's not 60. The big angle is 41/37. So guess what we're going to do? We're going to take that 41 degrees, 37 minutes, and we're going to divide it by 2. I'm going to divide the degrees by 2. I'm going to divide the minutes by 2. It's not going to work out very nicely, but we'll go one step at a time. Right? So if we go ahead and we divide 41 by 2, what do we get? Sophie? Good. 20 and a half degrees. And if we go ahead and we divide the 37 by 2, what do we get? We divide 37 by 2. What do we get? Connor? 18 and a half. Do you think I'm allowed to keep these fractional parts? No. So what I'm going to do is I'm going to take the fractional part and I'll change it. So I'm going to take the half minute. Isn't that 18 and a half minutes? Well, 1 full minute is how many degrees? 60. So 1 full minute is how many seconds? Sorry. 1 full minute is 60 seconds. So half a minute is how many seconds? 30. So do you agree this would be 20 and a half degrees, 18 minutes, and 30 seconds? Can I leave it like this? No. So now I still have that fractional part. I have the half a degree. Well, we know 1 full degree is 60 minutes. So how many minutes is half a degree? 30. So what am I going to do? This is going to be 20 degrees. And what am I going to do? Good. Add the 30 there. So that's 48 minutes and 30 seconds. And that is, what angle do we want to find? Angle OKM equals that. All right, number 6 is a great problem. Problems like this will be showing up all year. Problems like this will be on your test. Segment EH is divided by F and G in the ratio of 5 to 3 to 2. Right, so we are now dividing the section. Are we trisecting the segment? No, I did not say the words trisect. I said we are dividing in the segment into ratio of 5 to 3 to 2. Now, what you need to remember from Algebra 1, the minute you take numbers out of a ratio, the minute you take numbers out of the ratio, you put them in a diagram or you put them in an equation, you cannot just leave the numbers. This cannot be 5, 3, 2. That's wrong. Does anybody remember what you now have to put along with it the minute you pull numbers out of a ratio? Remembers? Okay, you need to put a variable with it. So when I pull 5, 3 to 2 out of the ratio, this is saying 5x, 3x, 2x. And then we're being told that the whole segment E to H is 30 units long. All right, find FG. So we want to find segment FG and we want to figure out which point is the midpoint. Well, right now, can we figure out which point is the midpoint? Well, I can, but that's okay. We can wait. We can wait to decide. Does anybody know an equation to solve for x? Somebody knew. Somebody knew. An equation to solve for x. It's not new. Jocelyn.
5x plus 3x plus 2x equals 30.
You got it. 5x plus 3x plus 2x equals 30. How come it doesn't equal 180? Because that's what I see all the time on the test. Connor?
Because we were told in the beginning that EH equals 30.
Okay, but why isn't it 180? Why doesn't EH equal 180? Why can't I assume it's 180? Caleb? It's not drawn to scale. Okay, why else? Olivia? Excellent. It is a segment, not an angle. It is a segment, not an angle. Straight angles equal 180. Do segments equal 180? No. Straight angles equal 180. Segments do not equal 180. All right, so now we have our equation. So we are at 10x equals 30, so x equals 3. Let's plug in now. 5 times 3 is 15. 3 times 3 is 9, and 2 times 3 is 6. So first thing we wanted to do was find FG. How long is F to G? 9 units long. Second thing we wanted to do was name the midpoint. Which point is the midpoint and why? Adam.
The midpoint's half because if you add 9 to 6, that makes 15.
Excellent. The point F is the midpoint. Why? Because from F to E, isn't it 15 units? And then from F to H, how many units is that? 9 plus 6, which is another 15. So wouldn't that make F the middle of that segment? So FG equals 9. The midpoint equals F. All right, I'm going to skip number 7 for now, and I need to go on to number 8. So here we are told that E and F trisect DG. If E and F trisect DG, what can I conclude? E and F. Bridget. Good. D, E, E, F, and EG are FG are congruent. We're told that DE is 2x plus 1. And now look how I'm marking this. D to G is 5x plus 13. Find EG. I need an equation to solve for x. Mariana? Okay, so I would say the majority of students are thinking that 2x plus 1 equals 5x plus 13. But look what you're saying. You're saying this one little part is the same length as this whole entire segment. Does that make sense? That one part of a segment is equal to the whole thing? No, so that wouldn't work. Olivia? I can't hear you. So minus 2x plus 1, and then what? So you're saying 5x plus 13 minus 2x plus 1. Okay. Chase?
3 times 2x plus 1 equals 5x plus 13.
Okay, good. Aren't all three of these segments equal? Do we have any expression for EF or FG? There's nothing written there. Since nothing's written there, can I say, okay, well, it has to be the same as DE anyway, so can I just put 2x plus 1 for all of them? So then isn't it 2x plus 1 plus another 2x plus 1 plus another 2x plus 1? Wouldn't that have to equal the whole entire length, which is 5x plus 13? Or you could have done what Chase said, 3 times the quantity of 2x plus 1. So now we combine our like terms. We're going to get 6x plus 3 equals 5x plus 13. Subtract the 5x. We get x plus 3 equals 13, so x will equal 10. Now I'm going to plug in. 2 times 10 is 20 plus 1 is 21, 21, 21. So what were we asked to find? We're asked to find the length of E to G. Is E to G 21? No, what's EG? Sophie? 42. We did 21 plus another 21. All right, bell's going to ring, so we are going to stop here. There is no homework tonight. Tomorrow, well, if you want to do this homework, you can for extra practice. If you want to pull extra practice problems, you can. I do want to do number 7. Can somebody remind me to go over number 7 tomorrow before we review? All right, I'll stop here.